Hi everyone, good morning all. Today we are going to discuss the problem. A pi attenuation circuit has been shown below. Find the y parameters y11, y12, y21 as well as y22. We need to find out and draw its equivalent y circuit model. But here in this problem, all are given in impedances. So that's why we are going to convert the circuit into admittance. So I'm going to replace and I'm going to call this admittance as YA, Mo, and this as YB, Mos, and this as Mosi, Mos. So how to write down YA? So YA is equal to 1 by 5 kilo ohms. So 1 by 5 is 0.2 into 10 to the power minus 3 moles is the YA value. And what is the value of YB is? YB is equal to 1 by 1 kilo ohm. So there's nothing but 1 into, it's come to the numerator, it is 1 into 10 to the power minus 3 moles. And what is the value of YC? So YC is equal to 1 divided by 2 into 10 to the power 3 ohms. Then automatically this is, so 1 by 2 we have is 0.5 into 10 to the power minus 3 moles. So now let us verify the things in more clarity. So now we converted the given network into modes and we are trying to draw the equivalent circuit. So with the input voltage as V1 and the current as I1, and we are going to have the admittance as YA and this as YB and this as some YC. And here we are going to have V2 voltage at this point and the current to this branch is I2. So now this is what the given problem to us. So from this we have to find out the y11, y22. Okay, so now what we are going to perform is, so already in the previous problem I have been solved how to find the current in these branches. So for more clarification I'm trying to do the procedure, so those who are new to this problem. Okay, so I am assuming the current in this branch is Ix, the current in this branch is Iy. So I'm going to apply Kirchhoff's current law at this node. Okay, so apply Kirchhoff's current law. So if when you apply the Kirchhoff's current law, what is entering current? Entering current is I1. What are the leaving currents in this branch is nothing but Ix. What is the current leaving this branch, which is nothing but Iy. So from here, how we can write down is, so how to, what is the voltage at this point? Already this is nothing but V1. So actually I require I1, directly I'm writing I1. And how to write down this Ix is, so generally we can write down V is equal, I is equal to V by R. So but there's no R. So this, we can write down this 1 by R as V into Y. Therefore, the formula for current I is equal to V into Y. What is the voltage at this point? The voltage is V1, and what is the admittance of this branch, which is nothing but YA. That is how to write down Ix. So how to write down Iy current? So the voltage at this point is V2. Since it is short circuited, this voltage will be moved to this point and this will be acting as an V2. And how to write down the current Iy? How to write down the current Iy is, we can write down V1 minus high potential minus low potential multiplied with Yb. Okay, this is the proper way of writing. So here I would like to segregate in the standard format. I1 is equal to, so take V1 as a common term. When you take V1 as common term, this is YA plus YB. Next one is minus YB V2. So this is the standard format. So already we know the standard equations. I1, I2 is equal to Y11, Y12, Y22 y21 y22 multiplied with v1 v2. So from here, when you compare with the standard format, so the expression of I1 is equal to v1 y11 plus v2 y12. This is the standard format. Let's try to compare it later. So many students may get it out, sir, why you assume the current Ix and Iy like this? So let's try to take this current. Okay, let's try to do by, so this can be solved by two methods. Let's try to do it by method one. Okay, in this method, what happening here is the same circuit I am taking. So here the entering current is I2, here the current in this branch is Iy. I am assuming a new current which is nothing but some Ia. So now try to apply. So you can take current direction whatever you want. Many people will teach you how to take the current direction like this only, leaving the node, or it should taken as only entering the node. So let's try to verify whether what doing is correct or not. So that's why let's try to check out how they are. So I'm taking in this branch, I2 is also entering, Iy is also entering, as well as Ia is leaving the branch. So now let's try to apply Kirchhoff's current law at which node? At this second node, at V2 node. So now what are the entering currents? Entering current is I2. What are the one more entering current is Iy. And what is the one more leaving current, which is nothing but Ia. But you see here, when you write down in the standard format, the expression of I2 is equal to y21 v1 plus y22 v2. This is the standard format. So this should be only in terms of I2. So that's why I'm writing I2. So I'm writing I2 is equal to Ia minus Iy. So therefore I2 is equal to, how to write down Ia? So Ia means how to write down current? V into Y. So how to write down Ia? So this is nothing but V2 multiplied with YC. Okay, we can write down minus, how to write down Iy. So Iy already we written. How to write down Iy? Iy is nothing but V1 minus V2, voltage difference multiplied with YB value. So when you do it, you can see here, so I2 is equal to V2 YC minus V1 YB. So minus into minus is plus V2 YB. Okay, V2 YB. So now, but it should be in the first term should be an V1 term. So that's why I'm segregating. So I2 is equal to minus V1 YB. So and I'm going to take V2 as an common term here. So when you take V2 as common, then you're going to get YB plus YC. So compare with the standard expression. So I2 is equal to Y21 V1 plus y22 v2. So when you compare this, then you'll get the things more clear. So what is the value of y11? Y11 is ya plus yb. What is y12? Is nothing but so this is minus yb is the value. Therefore y11 is equal to ya plus yb. And what is the value of y 12? So what is the value of y12 here is, which is nothing but minus yb. So coming to here, so when you compare this, the value of, so this is y21, so this is minus yb. So y21 is equal to minus yb. And what is the value of y22 is, this is y22 is yb plus yc. So this ultimately we got the same answer. But here previously, here I had taken that I2 is entering, Iy is also entering, and it is Ia is leaving the node. So let's try to do some modification. This is only method one I told. Let's try to do some modification. Then you will get a clarity how to apply nodal analysis. So this circuit is really very interesting, okay, when you do it by number of methods. If you do by one method, you don't feel any interesting. So now I'm changing the direction of current. So here this entering current is I2 and this leaving current is IT, and I'm taking this current as IB. So I'm neglecting this current. So now my current direction is like this. So now I'm going to apply the equations. So now we have to get the same expression. How we have been got the expression here, the same expression we should get. Then only we can say that whatever the current direction we consider in nodal analysis, the answer remains same. Let's try to verify whether it is happening or not. Okay. So now similarly, how we had done previously, let's try to, this comes under method 2. So let's try to apply Kirchhoff's current law at which node? So we are going to apply at node 2. So what are the entering currents? So only one entering current is there. That entering current is I2 is equal to, what are the leaving currents? IA is already an leaving current, and another leaving current. Previously we are taking this as entering. Now I am taking that current as IB, which is nothing but IB. Now what happens? So directly I require the standard format. I2 is there. I am writing I2 and IA is there. Sir, how to write down the current IA in this node? What is the voltage at this point? The voltage at this point is V2. So I can write down I is equal to V into Y. So therefore, I am going to write down as a V2 into YC plus, how to write down IB? Now current IB is flowing in this direction, okay, from 2 to 1. Then we have to write down high potential V2 minus V1 into YB value. Okay, so V1, V2, you can see this value, this is YB value. Okay, so now let's try to segregate in the standard format. So I2 is equal to V2 YC plus V2 YB minus V1 YB. So now let's try to write down in the standard format. What is the standard format? First it should be in terms of I1, V1 and V2. So here we are going to get V1 YB plus, you are going to take V2 as common, then you are going to get YB plus YC. Okay, so this is what the expression we had got. Let's try to compare with the standard expression. What is the standard expression we have? So I2 is equal to, I2 is equal to, what is the expression? We are going to have Y21 V1 plus Y22 V2. So when you compare this, what is the expression you are going to get? So this is Y21, this is Y22. You can compare here with this what we have been got. So Y22 is also the same. Y21 is also minus YB. So now what is your analysis is, whether you do by method 2 or by method 1, the answer remains same. This is how professionally to apply an nodal analysis. This makes you very clear how to apply it. Okay, so hope you understood what is the importance of this problem. So the resultant answer is Y a plus YB plus this one. Okay, now let's try to substitute in our problem. So we got this value, and already we have been compared, converted the impedances given into admittances. So now how to get the values? Okay, so here now we require y11. Okay, so what is y11? Ya plus yb. So what is the value of ya is 0.2 into 10 to the power minus 3 plus, what is the yb value is 1 into 10 to the power minus 3. So similarly, what is y12? Y12 is minus yb. So this is nothing but minus, means minus 1 into 10 to the power minus 3 moles. Next, what is y21? Y21 is minus yb. What is the yb value? 1 into 10 to the power minus 3 moles. Next one, what is y22? Y22 is yb plus yc. So 1 into 10 to the power minus 3 plus 0.5 into 10 to the power minus 3 moles. Okay, so when you compare, then this is the resultant values of, so this if 1 plus 1, this is 1.2 into 10 to the power minus 3. So this is also 1.5 into 10 to the power minus 3 moles. So this is the resultant answer what we are expecting to be drawn. Okay, now what I have to do is we have to find the equivalent circuit for this one. Okay, so how to find the equivalent circuit is also very important. So coming to the equivalent circuit, so in order to draw the equivalent circuit, we require the standard expressions of y1 and y2. Okay, already we have been written the standard expressions here. So this is like just by listening you will not get anything. Just you have to first listen and you have to practice of your own. Then all the things are very clear and better. So here we have V1, V2, I1, I2. So now what are the expressions of I1 and I2? So I1 is equal to Y11 V1 plus Y12 V2. This one expression. Next one, I2 is equal to Y21 V1 plus Y22 V2. First let's try to do for this and later we can substitute the things better. Okay, now we want to draw this equivalent circuit. So this, you consider this as an input port and consider this as an output port equation of KCLs. So V I1 is there. Okay, so I'm taking a voltage V1 and the current entering the branch is I1. So how to draw this, I'd already explained in the previous videos of Y parameter. You just look in that video, you will get a clarity. So now you're going to have an admittance of Y11. This is Y11. The voltage at this point is V1. Okay. So now what happens here is, let us assume some current which is flowing in this branch. Okay. So this mark this current as some Ix. Okay. So the current which is flowing in this branch is Y11 V1, and there is a current which is related to output port that we are going to represent with a dependent source, and current is shown downward and the value is Y12 V2 and the current is Iy. So now when you apply the KCL as already how we applied, as I1 is equal to Ix plus Iy, you will be getting the same expression. Now let's try to do for the output port. At output port also we are applying a voltage of V2 and it is a current I2 is drawn like this, and what is the admittance at output port we are going to have, which is nothing, Y22 is the current. So therefore the voltage at this point, the voltage at this point both are same. So this current you assume it as some Ix. So or some Ia. Now this current is flowing like this, and you see here this is with respect to output port, directly we had drawn y22, but this element y21 v1 is referring to input port. So we cannot, if you want to refer to the input port, we have to use an uh, dependent source. So I1 is referred to input port V1, this one. Okay, so that's why we are showing with a current source which is leaving, and assume this current is IB. So which is nothing but Y21 V1. Okay, just join input port and output port. This is the resultant equation. So here if you apply the KCL at this point, I2 is equal to IA plus IB. Okay, so when you apply the current division, all you just to see here, I2 is equal to IA. How to write down IA? IA is the voltage V2 multiplied with the admittance of Y22 plus, how to write down IB? So what is this value? Y21 V1. So you see here, this and this both are same. That is how to get it from the same. Okay, that's by use that we have been drawn. Okay, so now we want to substitute those values. Okay, so what are those values we need to substitute here is, so the value of Y 1 2 is how much? So substitute this is y2, no, right? This is minus 1 into 10 to the power minus 3 v2. Next one, what is the value of y11 we have been got? So this is 1.2 into 10 to the power minus 3 moles. And what is this value of y21? Y21 is minus 1 into 10 to the power minus 3 into v1. What is this value? This value is y22. What is the value of y22? 1.5 into 10 to the power minus 3 moles. This is very interesting when you solve it of your own. Okay, so you have to invest some time. Okay, so this is how to find out the y parameters. So successfully we have been find the y parameters and we have been drawn, or the question actually asks this, the equivalent circuit. So this is the equivalent circuit of drawing. This is how to solve a problem when you get in academic questions, and this is very important in competitive problems also. Okay. So hope you have, so what is the outcome of this lecture is, you have been find the y parameters and you have been learn how to get the write down the y parameter equation, and you have been understood how to find method 1, which is nothing but by taking one is entering and another is also entering, and you have understood how it is living. So you have been become expertized in the nodal analysis, and you have been understand how to drive the equivalent circuit. So if you feel the video is really useful, please give one like in the video and please share with your friends. And if you have any doubts, let me know in comment section. I will answer. And if you are watching for the first time, please kindly subscribe to the channel. This is a free channel for the benefits of students and faculty. So hope you understood a lot. We'll meet in the next video. Yours obediently from. We'll meet in the next video. Thank you for watching.